just want to spend 10 minutes or so showing you some demonstrations of big data at work. I want to get beyond this, what I believe is a little bit of a hyped term at the moment. Big data is kind of thrown around kind of loosely. And I saw this slide when I was preparing this presentation. I thought it was really good. Big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they're doing it. I'm now going to claim that I do big data quite a lot. And actually, you all use big data all the time, but you might not be aware of it. Much of the world that we live in is based on the collection and the analysis of big data. It's not necessarily something scary, although with a lot of technology enhancements that come along, it's important that we understand what's going on behind the scenes. So hopefully, the demonstrations I'm about to show you will give you some clue as to what goes on behind the scenes with big data, and at least put in your mind some of the questions that you need to be thinking about and asking. The first thing, and I agree with Mike here particularly, is that this is relative, depends upon who you are, when you're looking at the data, what industry that you come from. So the old Father Ted analogy of the difference between a cow being small or one far away, they are different things. It's based on your perspective. Size is relative to the application that you are working on. From a geographer's point of view, as geoscientists, as geospatial technologists, we believe that we're quite used to handling big data sets. I'll give you a number, 20 petabytes. A petabyte is 1,000 terabytes. Now, if you have a PC at home, your PC probably has a hard disk that's maybe 1 or 2 terabytes. So a petabyte is 1,000 PCs. Google Maps, I'm going to pull up Google Maps now, has about 20 petabytes worth of data on servers distributed around the world that give you this experience of being able to have a look at a map of where we are in Kensington, pull up satellite imagery of that map, and the thing that's obviously really exciting to people, you pull up your little Street View guy, you put him on, and there you are standing outside the Royal Geographical Society and having a look round. There's an awful lot of data to allow that to happen. We've driven these little cars all over the world, taking pictures, being chased by villagers with pitchforks, trying to collect this information that will allow you to have that sort of sense of place, what it feels like to be at that particular location. And that's in many ways an obvious demonstration of what big data is. There's a lot of data, satellite imagery, photographs, information about millions of different activities that go on in the world, all available to you there in one application. So that's sort of one perspective on what 20 petabytes worth of data means. Another perspective is this one. If you think about the smartphone that you've got in your pocket and that you may well be tweeting with, we all carry them around with us, each one of those probably can store maybe a gigabyte, 2 gigabytes worth of data. If we take every smartphone in the UK, that's about 20 petabytes worth of data as well. And that's a different way of looking at big data, and perhaps in many ways a more interesting and exciting way is that these devices can be capturing information, whether explicitly in terms of you taking pictures or making tweets or Facebook status updates, or we can, with your permission as always, collect information that provides data sets that are useful in other ways. And I'll give you a demonstration of that. I click here, take you to Google Maps, and this is showing you the real-time traffic data for London. And the data is being sensed. We call this probe data. It's taking the locations of mobile phones as they move around in people's pockets or in their cars, in their buses, however they're traveling. We anonymously probe that data and use that to build up this map of speed on the roads of London. You couldn't put in place enough cameras and hardware in the road to do this. The probe data that we're collecting allows us to build up this database that is real time, and if you want to get driving directions, should you be foolish enough to drive through London, that information will be used to make sure that the data is accurate and up to date. The other information that you might find interesting, another form of big data that is being collected by users is in terms of imagery. Mike mentioned the fact that imagery is a big source of big data. Well, here's an example of big data. This is photographs of the Victoria Monument that have been collected and taken by people, have been posted online. And what we're doing is we're stitching those pictures together to give you a tour walking around the monument. And it gives you that sort of 3D effect because we're stitching all these pictures together. And you know, at some point in the future, you can imagine a position where there are enough photographs of certainly the city centres of the world to build up this kind of completely immersive view that you can go from one picture to another picture to another picture and see everything photographed. Okay. Next thing I want you to talk about is the geography of big data, and I think this is an important point. By the geography of big data, I mean that actually for us to really do this kind of clever analysis, and whether that's Google or any other organization, we need to bring together the raw data, the many millions of records that might have been collected via those various techniques, and the ability to process that data into one place. It's not going to work in terms of big data if we have the processing capability, i.e. lots of computers here, and the data somewhere else. To really make the most of big data, we need to bring the two together. And I want to take you now off to North Carolina, to one of our data centers that Google maintains. We have about a dozen data centers around the world. And I'm just going to take you inside this data center, show you a bit what it looks like, if I can get there. Here we go. You won't go in there. It's a security issue, I tell you, that's what it is. Go on, little peg man. Ah. So if I get in this way. Go in the back door. Right. Here we are in the data center. I'm going to take you in, and this is what a data center looks like. You might, if you're really observant, see the security guy there, who's actually a stormtrooper. We take security really, really seriously of these data centers. I couldn't visit one of these data centers because of that key point. To really make the most of big data, we need to bring the information, some of which might be obviously personal data, some of which might be data that, with additional processing, can be turned into personal data. We need to keep this as secure as we possibly can in one place because the ability to do the processing needs us to do that. Now, why we need to do that, I'm going to explain with the next example that tells you in some ways about the scale of the issue that we're talking about in terms of processing big data sets. And I'm going to take you on an adventure in time and space. If you haven't noticed, there is a real TARDIS outside Oscorp tube station. If you never visited it, go and have a look. And if you go and visit it in Google Maps, there's an Easter egg for you to discover if you go and visit that particular location. I'll give you a hint. Okay, so let's have a look at an adventure in time and space. What I want to show you now is some technology that we call Earth Engine, which allows you to manipulate very large amounts of data. And what I'm going to do is zoom in and we're going to look at some satellite imagery. We've got now in a data center, or in a number of data centers, all of the satellite imagery that has been collected by what are called the Landsat missions. They've been on for the last 30 years or so. And it's many, many petabytes worth of data. And it's very rich information. We can use it to find out about the landscape around us. I'm just going to change the way this data is displayed. You see, this is a composite of all the imagery from last year. And I can look at the world using slightly different eyes, if you like, using different sensors on the satellite. And what I've done is I've changed that image to what's called a false color composite, which is looking at infrared. And infrared is a way of looking at how light is reflected by vegetation. The brighter the red on the image, the more leaf matter there is in that particular location. And the world is divided up into pixels, areas about the size of this lecture theatre, about 30 meters by 30 meters. As you can imagine, if you do that for the whole planet, and you do that probably about every month for the last 30 years, that's an awful lot of data. And to process that data, to carry out interesting analysis, so that you can find out, for example, how forestry has changed around the world, needs you to bring those two data sets together. So if we now go and look at the time component, when you do that, and we've done that with the University of Maryland, you can bring together these really large data sets. The ability to process those large data sets allows you to discover things that perhaps were not obvious before. Let me just take you to, let me move the screen up. Let's go to this location in Indonesia. This is showing you how forest has changed, whether there's been a loss or gain over the 12-year period from the year 2000 to 2012. And I think this reflects Mike's point. What's really interesting with big data is when you can start to look at trends. You can look at patterns changing over time, where you're dealing with very large data sets, often coming from the physical sciences because that's where we know the most about. But you can start to apply some of these techniques to social sciences as well, and start to see patterns that emerge that you can only see over time. And it's only possible to see with this ability to handle very, very large data sets and to look at those patterns as they emerge. So as you would imagine, being a technologist, I'm very optimistic about this technology, the ability to collect and analyze patterns in ways that we've not been able to do before. You know, it's creating a new telescope, if you like, a new way of analyzing the world around us. There are pitfalls. We do need to worry about privacy and data security. Most of all, you as individuals need to be aware that this information is being collected and how it's being used. But there is huge potential with this technology. Okay, that's all I wanted to talk about. If you want to mention me in your social networks, these are my details here. Thank you very much.